let me just start by maybe trying to ground a little bit of what we're doing. People, well, certainly my daughter, when I talked to her about the project, said, isn't this just like a search engine? Can't I just Google questions in behavior change and I'll get something back? And try it, it's interesting. You get lots of things back, not always what you expect. So I want you to think of this maybe as a set of graduated problems. Internet search is helping you find things by keywords. Okay, it's good for basic information retrieval. We want to get a little bit further. The next level might be to look into the documents and to try and pick out one or two facts in the documents, so to start to summarize the knowledge that's in there. We want to get at least to there. And then the third step would be to say, can I actually start to synthesize things? Because imagine you've been invited to the coolest party in the world. It's the Human Behavior Change Party. Right? You're all going to be talking about research papers. But the rules of the party are, it's not that exclusive, actually. We're going to double the size of the party every 8 years because there'll be more and more publications. And you're only allowed to talk to 13 people because that's the average number of citations on a health and wellness paper. So that's the kind of circle of connection of one publication. You don't have to be too mathematical to realize that eventually the number of publications goes like this, but the number of connections goes like this. So you've got a basic problem of finding information and then connecting facts together. Okay? So actually you're quite gregarious as a community because mathematicians only cite 3 people. So we really have to help them. Okay? So let me move on quickly because I'm eating into my time. So here's what I thought I'd like. Right? I'd like somebody who can look at not just 1 or 2 documents for me and write a report, but look at pretty much all of the documents in a particular area, who can be my research assistant. I want them to do a few things. I want them to be able to read really fast, right? And I want them to be able to retain facts. Because I don't know about you, but I find as I get older, I forget things that happened 5 years ago. I can't remember things that happened 10 years ago. And so things that I've read, facts that I've accumulated, I don't want to lose them. I want the computer to remember them all. So we have a recall requirement. Then I'd like it to make systematic connections. And this is back to the idea of an ontology. Okay, so that we've got a way of organizing the content of these documents. So we will be doing quite a lot of work to not just look into the documents, find out what the words are. That's kind of natural language processing 101. But we will then be trying to make sense of those words and doing some clever processing to try and connect them back to the formal terms that are in the behavior change ontology that you saw earlier. What's the power of that? That means then that you can start to query consistently over all of the documents that we've summarized by the system. So if you ask one simple question, the system can very quickly look over the hundreds of documents that it's indexed, or the thousands, or the hundreds of thousands. And so what you begin to get is a view across many, many, many sources of information. This is an interesting one. I'll talk a little bit at the end, if I have time, about the kind of things we're doing right now in other areas related to the general area of health and wellness. But this idea of making an unbiased assessment. What does it mean to state something in an English sentence? Think about how you write things. You know in your head what you want to do, and then you have to turn it into formulaic prose, because that's what the reviewers like to see. And so you lose something. We want to try and get back to making an unbiased assessment of what you were trying to infer when you wrote that sentence down. Okay, by looking at the context of the entire document, by looking at what other people might have written in this particular area, and trying to say, what's a reasonable assumption about what they were trying to say? Okay? And then, of course, no small problem, we want to get it all into a nice compact form in a not too big computer so that other computers can use it. And so Susan talked a lot about, and Robert and Mary, about open science, about making this accessible and how we want people to use the system. So very much a part of this is to provide interfaces. So as this thing starts to breathe and live and take over, we want people to come along, query the system, and use it to build other things. This is not a closed system that we're building for just us. It's for everybody who's interested in accessing it. Now, what are some of the small and sort of computer science-y type problems? How can I take knowledge that's expressed in different ways by different people in different sources, join it all together and make sense of it? This is really difficult. Sometimes people are verbose, right? Sometimes they're not. Sometimes they write text to make up a certain number of pages for publication. Sometimes they don't. We can find that information is really only in a couple of small places in a publication. And we need to figure out how to denoise all the other stuff that's not really that relevant without losing the real deal. Ambiguity is a really big one. I think we talked for most of our meeting today about uncertainty and how we resolve ambiguity. What did that person really mean? What does that score really mean? What does that confidence interval really mean? Okay, so that we can represent, again, consistently across the knowledge base. And then assign confidence. A couple of people put their hands up, right? So a few people, I presume, have been burned by building overly complex programs that just don't work. They can't run in efficient time. They can't run on reasonable computers. We will have the same problem here, because the kind of key balancing challenge is get all of the richness out, put it into this organizing ontology format, and please don't make it so complex that no computer can actually crunch the numbers in there. So quite a lot of clever engineering will have to go on to make it work. So now I've kind of hopefully sort of set out a few of the challenges that we have. Actually, we're fairly far progressed. Has anybody heard of Jeopardy and Watson and playing games? Okay, so a few people. Good. So essentially that's a question and answering system that played against humans. Okay. It was able to take a vague question, a vague statement, and find the correct match, if you like, in a knowledge base. So it was about question and answering. We've taken and advanced those kind of techniques and applied them in the health domain. So Medical Recap scans through PubMed papers and allows you to extract risk information about treatments for oncology. So what we can do now is scan through the papers, go into the kind of tabular format. So it's quite detailed work. And when a physician types in a particular treatment regime, we can give them a risk score, so that it allows them to decide whether or not it's a reasonable set of treatments to use in this particular case, all based on natural language processing. Okay, so the same kind of things we'll have to do here. Watson Oncology Advisor takes that a step further. So Watson Oncology Advisor provides a physician with a ranked set of treatments based on all of these kind of multidimensional scoring algorithms. Robert mentioned all of the different modes, all of the different measurements, all of the different features that you might encounter in a document. How do you balance all of those to provide you with ranked, assessed scores? We're already looking at those kind of problems. And the latest one is really cool. It's not out there yet. It's still in the labs. We're teaching machines to debate like humans. Okay? So if you were to think about what that requires, right? You have to be able to assess vague information. You have to be able to take an assertion, and you have to decide whether or not it's just a wild accusation or whether it's based on fact and evidence. And so much the same kind of things as we'll be doing with the human behavior change documentation as we process them. Okay. Now, I'm going to kind of stop here, because very quickly I exhaust what you want to do with documents when they're organized in an ontology. You can query them. What happens next is really cool. Right? It's when we start to do some machine learning and some artificial intelligence. And I'm going to hand over next to my colleague and collaborator, John.